Welcome back to Aerospace and Mechanical Lab 1. Today we are going to talk about the flight simulators, and we are going to learn essentially how to fly and how to modify flight parameters. This is mostly an aerodynamics study, so think of this as one of your fluid mechanics related labs. And it does have a fun side in which you will learn how to fly an airplane. We do have two different types of flight simulators. One is only used for the lab, and the other one is a real flight simulators, which you will learn how to use in your actual lab. Okay, so we will talk about in today's lecture, we will talk about primary flight controls, which do include elevators, ailerons, and rudders, and we'll talk about the flight performance of an aircraft and essentially how to evaluate the flight performance of an aircraft. And we'll move on to what you will need to do for your Lab 3 flight mechanics. Okay, we have three different primary flight controls. You have to keep in mind that these are primary flight controls, meaning that there are other flight controls that are available in an aircraft, but they are not the main source of control. Okay, so to understand the primary flight controls, we need to understand the primary movements of an aircraft. The first primary movement is the pitch of an aircraft, or lateral movement around the lateral axis. So essentially movement in this direction. The second primary movement an aircraft has is the roll of an aircraft. So essentially rotating around this axis. It's going to be roll of the aircraft. And the third primary movement an aircraft has is called the yaw of an aircraft, essentially rotating around this axis. So three different primary movements of an aircraft, which will require three different flight controls, primary flight controls. The first flight control we want to talk about is the elevator control, which essentially controls the pitch of an aircraft. The elevator is located right here at the tail of the aircraft, usually at the end of the tail of the aircraft, and it will move up and down, and that's how it will control the pitch of an aircraft. Ailerons are in charge of controlling the roll of the aircraft. So the ailerons are located right here at the ends of an aircraft, and they move in the opposite direction. And we will talk about the mechanism on how they work, how they actually cause the roll in an aircraft in a second. And the rudders are located on the tail of the aircraft right here, as you can see, most generally right here, and they are in charge of this type of movement. So essentially movement around this green axis. To understand these better, there is this YouTube video that I always show in my classes. So let's actually watch this YouTube video.
An aircraft is an amazing machine, capable of flying in any direction by rotating about in 3 dimensions. These are called axes of movement. The average location of an aircraft's mass is a point that is called the centre of gravity. So if you suspend an aircraft from the centre of gravity by a line like this, the aircraft remains perfectly balanced. Each of the 3 axes moves about the centre of gravity. The aircraft's principal axes are normal axis, drawn from top to bottom, lateral axis, drawn parallel to the wings, and longitudinal axis, drawn from tail to nose. Each axis is perpendicular to the other 2 axes. Let's look at each individually. The rotation about lateral axis is called pitch. This movement changes the vertical direction of the aircraft's nose. The rotation about normal axis is called yaw. This is the movement of the nose of the aircraft from side to side. The The rotation about the longitudinal axis is called roll. This is the movement of the aircraft's wings. One wing goes up, the opposite wing goes down. So in summary, these are the three principal axes of movement.
Okay, let's go back to the lecture. Okay, so elevators. How do the elevators work? First of all, the elevators are controlled by the yoke of an aircraft. And the yoke of an aircraft, let's move to a different, this is this. Essentially, the steering wheel of an aircraft is called a yoke of an aircraft. When you pull the yoke towards yourself, your aircraft is going to pitch up, and when you pull it away from yourself, it will pitch down. So meaning when you pull it towards yourself, it will go up, it will gain altitude, will try to gain altitude at least. And if you pull it away from yourself, it will lose altitude. So how does it work? When you're trying to gain altitude, what's going to happen is you are going to move the elevator in the upward direction. You can see this is the elevator. It's very small region. This is the elevator. When you pull it towards yourself, pull the yoke towards yourself, this will move up. And what happens is it's going to decrease lift, the aerodynamic force that is pushing the aircraft up at the back of the aircraft. So the tail is going to go down, and the nose is going to go up. And because of the presence of the wings, this nose going up means that the aircraft is going to gain altitude. And if you want to reduce the altitude, you just have to, as I said, push it away, push the yoke away from yourself. And then what's going to happen is the elevator is going to move down. It will have this type of shape. And this will cause an increase in the lift in the back of the aircraft, which means that the nose is going to go down and you are going to lose some altitude. Okay. Ailerons work a little differently. They are a little more complicated. As I said, this is where the ailerons are located. You can see the ailerons move in the opposite direction. This one has moved down, this one has moved up. So why does this happen? The idea is when one of these ailerons move up, you are going to see a reduction in lift in this direction. And when this aileron on the opposite side moves down, you are going to see an increase in lift. Why do we see a reduction in lift? We're going to talk about this a little bit later as well. But the idea here is that the curvature of the wing is responsible for an increased lift. The most generalized type of idea about the relationship between lift and a wing. So when you reduce the curvature by moving the ailerons up, you are going to reduce lift. And moving these down, moving the ailerons down, let's go to the previous page. See, this has caused a reduction in the curvature. But when you move it down, it will cause an increase in the curvature, which will result in a higher lift. So when you have higher force, higher upward force on one wing and lower upward force on the other wing, what's going to happen is this wing is going to go up, roll up. This wing is going to roll down. And the aircraft is going to roll, and that roll is going to cause a turn in an aircraft. You have to keep in mind that this roll usually is accompanied by an adverse yaw, which is a moment in this direction, as you can see, and it will cause a reduction, a small reduction in altitude. And since the wings of the aircraft are actually moving, see, this wing will go down and this wing will go up. We don't want to use roll on the ground to turn. When you're on the ground, you want to use a different mechanism to turn. And that different mechanism is called rudders, right? So essentially, this tail is controlled by the pedals that are very similar to the gas and the brake pedal in a car, right here. You can see these are the pedals. And you can slide them in and out. Essentially, by pushing them, they will go in, slide in, and slide out. And this sliding in and out is going to cause a movement here. And this movement, this rotation, is going to essentially create a higher curvature in one direction or in the other direction, which in turn is going to create a higher aerodynamic force in one direction, which in turn is going to cause a movement of the nose in the left and right direction. So the benefit of this type of turn is that the wings of the aircraft are not rolling at all. So which makes it easier to turn on the ground without harming the wings of the aircraft. So essentially, when you slide the left, the idea is when you slide the left pedal in, the curvature in this direction is going to become greater. Aerodynamic force on the tail is going to push the tail of the aircraft right, meaning that the nose is going to turn left. And if you slide the right pedal in, the reverse is going to happen and your nose of the aircraft is going to turn right. You can also control the brakes of an aircraft using these pedals. Essentially, if you push the top of the aircraft, the top of this pedal, if you push it in, you are going to engage or release the brakes of an aircraft, of a Cessna aircraft that we actually use for the lab. Okay. So let's talk about the forces, aerodynamic forces that are present in any type of flight. We have four main forces that are going to be important in flying an aircraft. One is weight, that is counteracted by the aerodynamic lift, right? So the weight is going to pull your aircraft down, lift is going to push it up. The other one is drag, which is always present. If we want to have any lift, we will definitely have any drag, and drag is counteracted by thrust, which is provided by the engine of the aircraft. So a glider, for example, doesn't have an engine, meaning that doesn't have any thrust. That is why gliders always lose altitude. Essentially, there is no way you can fly indefinitely with a glider. But as long as you have enough fuel, you can fly indefinitely with a jet aircraft, for example. So aerodynamic forces are important for us, are lift and drag. And using the flight simulator, you can actually export the lift and drag data during any type of flight that you are performing using the flight simulator. And the idea is you actually need to record this data, lift and drag data specifically, and the angle of attack. We will talk about angle of attack in the next slide, and do some sort of an analysis, aerodynamic analysis, and present that analysis in your lab reports. Okay. So before talking about the angle of attack, we have to talk about airfoil. And airfoil is a two-dimensional cross-section of the wing. Very simple. Essentially, when you cut a wing, the cross-section of it is going to look like a teardrop shape, an airfoil. And this airfoil can have a high curvature or low curvature. The curvature of an airfoil is called the camber of the airfoil. And the angle between the direction of the wind, direction of the movement of air, and the chord line of an airfoil, essentially the line that passes through an airfoil that connects the beginning, the leading edge, and the end, the trailing edge of an airfoil. That angle is called the angle of attack. Our goal is to maximize lift and minimize drag at the same time. So the goal, the design target in aerodynamics is always to maximize the lift to drag ratio. That is always the case. Okay, so to understand and be able to compare different types of aircrafts with each other, we define these dimensionless parameters called the lift coefficient and the drag coefficient. Lift coefficient is lift force divided by the dynamic pressure, which is 1/2 density of air multiplied by velocity of the aircraft squared. So 1/2 rho v squared multiplied by the surface area of the aircraft. Drag coefficient is very similar to the lift coefficient in definition. It is drag force divided by dynamic pressure Q infinity. Again, this is 1/2 rho density multiplied by v squared, velocity of the flight squared, multiplied by the surface area of the aircraft. Okay, so your job in the lab is going to be recording the lift and drag and recording the angle of attack, which is essentially you just have to use the software for these. There's nothing special you need to do. And based on this, and you also have to know the surface area of the aircraft. Again, this is an information that you can find online or using the software. And record the flight velocity as well as the density, as well as finding the density of the air at different altitudes. Using all of these informations, you can calculate Q infinity, S, and L, and eventually lift coefficient and drag coefficient. And your job is going to be to graph changes of lift coefficient with respect to angle of attack, changes of drag coefficient with respect to angle of attack, and changes of lift coefficient with respect to drag coefficient, which is called, this last one is called a drag polar. Okay, so lift coefficient versus angle of attack, alpha. This is one of the most important graphs you will ever see in one of the most common graphs you will ever see in an aerodynamic textbook. And this graph is this type of analysis will be done for any vehicle in which aerodynamic analysis is important. Aerodynamics is important, like electric vehicles, for example, or aircrafts, of course. So what does this graph tell us? This is a graph that tells us the variation of lift coefficient versus angle of attack. As you can see, we can have negative lift coefficient. What does a negative lift coefficient mean? Going back to definition, a negative lift coefficient only means a negative lift force. And what does a negative lift force mean? It means that the direction of lift is actually opposite the direction it should be, meaning that it is pushing the aircraft down. So it is possible for us to create negative lift to push the aircraft down. So essentially, if this wing rotates to very low angles of attack or negative angles of attack, you are going to see a reversal in the direction of the lift. Is that always a bad thing? No, depending on the conditions. But usually we don't want to see that. Like in general types of flight, you definitely don't want to see your lift working in the same direction as your weight of the aircraft. Okay, so we start with negative values. There is a point at which lift coefficient will become 0. The angle of attack, which was the angle between your chord length, your airfoil, your wing, and the direction of the movement of the air, the wind direction, at that 0 lift is called 0 lift angle of attack. So when you are graphing for your, in the lab, when you're graphing this graph for your own lab, you essentially have to find this value for your specific aircraft, 0 lift angle of attack. And the rest of variations should be linear. Essentially, as you increase the angle of attack, your lift coefficient will increase until where the flow separation and reverse pressure gradient happens. We don't need to know the physics of it, but the point is, at some point, we will reach a maximum for lift coefficient. So increasing the angle of attack beyond this point is not gonna be useful for us. There's a limit to increasing the angle of attack. So what I want from you in your lab report is to essentially find these 2 points: maximum lift coefficient, zero lift angle of attack, and graph this CL versus alpha and CD versus alpha, drag coefficient versus angle of attack, and CL versus CD. Okay, so the software we're going to use is called X-Plane. X-Plane is a comprehensive flight simulator. It is commercially available. You can buy a license for it easily. And it's essentially a flight simulator game like the Microsoft Flight Simulator. The difference between X-Plane and Microsoft Flight Simulator, at least the older versions of the Microsoft Flight Simulator that I have used, is that X-Plane comes with a CAD software for free. You can actually design and create an aircraft from scratch yourself and fly it in the X-Plane. And it also lets you record the flight performance data like lift, angle of attack, flight velocity, drag, and all of these other data. So the idea is you take this X-Plane, you learn how to fly with it, and we usually use Cessna 172 for this lab, but if you want to use a different aircraft from the library of X-Plane, you are welcome to use a different aircraft. And then what's going to happen is we are going to take that specific aircraft we have learned how to fly with, take it to the CAD software that comes with the X-Plane. It's called Plane Maker, and this is the environment of it, right? And change a couple of flight parameters like the length of the wings and whatnot, right? And then see how would that change affect our flight performance. So we are going to compare the flight performance between these two scenarios, between the vanilla aircrafts that are present in the library and the modified aircrafts that were not present in the library. You essentially have created those things. And you want to make sure that you delete your modified aircraft when you're done with the lab. Okay, if you want to learn more about Plane Maker, there is this tutorial on YouTube. I will share a link to this tutorial. This was not made by me, of course, and you can learn more about X-Plane here. And you can also install a demo version of X-Plane to play with on your own PC. I think it is limited to 40-minute flights, but everything else, and it has only a limited number of airports in it, but everything else is open to you. You can create your aircraft, you can create whatever you want to create and play with it essentially and learn more about aerodynamics and flight mechanics. This is the lecture for today. Thank you for joining us, and have a good rest of the week.